Praised physics students. Student goes to the roof of the school, 14.2 meters above the ground, and throws a pumpkin straight down with an initial speed of 19.4 meters per second. With what velocity does the pumpkin strike the ground? So we wrote our gnomes. Our initial velocity was 19.4 meters per second. The displacement was 14.2 meters, and the acceleration was negative 10 meters per second squared. And we're looking for final velocity. So we used equation number 4. We plugged in our initial velocity, acceleration, and displacement. We got that VF squared equals 92.36, and we square rooted it and got 9.61041102 meters per second for the final answer.
That's nice. Now, what do you Gage? Are you comfortable with your answer here?
Yes.
Okay. Now let's look at this. So if you throw the pumpkin down from the top of a building, 19.4 meters per second, should it be greater than or less than that number? Greater than. Because when you throw something down, is it going to slow down? Or it's actually going to keep speeding up due to gravity. Now your numbers are all correct. You'll see it in just a second. You didn't make any major mistakes. It has to do with the way the thing is drawn, set up. So let's go ahead and talk about that. Could you hang that up there for him?
Yes, sir.
Again, that's why doing these just in class. Oops.
Wow. Oh, thanks, man.
Try to help you out.
Good catch.
Yes.
That's why not doing these outside of class is a lot harder, because the first time you make through this, most of you are going to make the same mistake. Now all Gage has to do is he understands most of the problem. Now all he has to do is just make a minor adjustment. And he's going to learn about that here. And a lot of you are going to be learning for the first time, unfortunately, because it's the first time you saw the problem. So, like I said, what it has to do is the scaling of everything. I'm going to draw a little picture here. Praised student. We'll tether her off. Okay, so she doesn't fall. All right, she's throwing it down. All right, she is at 14.2 meters high. Okay, so now, which way is negative, which way is positive in this picture? Negative's that way, positive's up here. So, which way is the velocity moving? Positive or negative? Okay, now which way is the displacement? Is it positive or negative? In other words, which way is this thing traveling? Negative. And that's where it comes out. If you put a negative in here, it actually squares out, so you still get 376.36. When you go this, though, here, it makes this a positive, and so it's 376 plus 284. It's 660. Then it's the square root of 660. Which is 25.7 meters per second. So again, just a little adjustment. You did a really good job. Okay, unfortunately,